And open your camera now. Good evening, everyone. Imagine an object so powerful that nothing, not even light, can escape its gravity. These mysterious and fascinating objects exist throughout the universe, and they are known as black holes. Understanding black holes is important because they help scientists learn how galaxies evolve and the laws of physics behave under the most extreme conditions. To prepare for this speech, I researched black holes using reliable scientific sources, including Space.com and Scientific American. Today, I will explain how black holes form, the powerful gravitational effects they create, and how scientists study them. First, let's talk about how black holes form. Black holes begin with extremely massive stars. These stars spend most of their lives producing energy through nuclear fusion, which creates an outward pressure that balances gravity. However, when a star runs out of nuclear fuel, that balance is lost. Without outward pressure, gravity takes over and the star collapses inward. This collapse often causes a massive explosion called a supernova. After the explosion, if the remaining core has enough mass, it continues collapsing into an incredibly dense point. At this stage, gravity becomes so strong that nothing, not even light, can escape. This is what we call a black hole. Now that we understand how black holes form, let's look at their powerful gravitational effects. Black holes have some of the most extreme effects in the universe. One major effect is the formation of something called an accretion disk. This is a swirling disk of gas that dusts and spins rapidly around the black hole. As this material moves faster and faster, it heats up and emits large amounts of energy. Another effect is something scientists call spaghettification. This happens when an object gets too close to a black hole and is stretched apart by the intense gravitational forces. Black holes can also collide with each other, releasing enormous amounts of energy. According to astronomy writer Phil Plait from Scientific American, when supermassive black holes collide, they increase an incredible amount of energy across space. Finally, let's explore how scientists study black holes. Even though black holes cannot be seen directly, scientists have developed ways to detect them. One important method is observing X-rays. As matter falls towards the black hole, it becomes extremely hot and emits X-rays. According to science writer Robert Lea from Space.com, scientists use advanced instruments to detect X-ray emissions, which helps them identify black holes and understand their behavior. Another method involves detecting gravitational waves. These are ripples in space-time that occur when massive black objects, like black holes, collide. Scientists also study how black holes affect nearby stars and galaxies. By observing how stars move, they can infer the presence of a black hole. In conclusion, black holes form from collapsing stars, create extreme gravitational effects, and are studied using advanced scientific technology. Black holes are among the most fascinating objects in the universe because they show us how gravity and physics operate under the most extreme conditions. Even though we cannot see black holes directly, studying them allows scientists to uncover deeper truths about the universe and its origins.